When dealing with batteries that are not ideal batteries, we do have to consider that these batteries do have some internal resistance. And I've drawn a battery here instead of using a symbol for it, so we can redraw it with internal resistance. As we will see here, I'm just going to put the battery in this dotted line box so we can see what's really going on. A battery, a real life battery, acts like an EMF source. Here's negative, positive, as if there's actually an internal resistance inside it. So this is EMF E, and we usually use a lowercase r for the internal resistance here. So when I close, if this is a 1.5 volt battery, when I close this so that there's current flowing through the battery, it no longer acts like a 1.5 volt battery. It acts like lower than 1.5 volts because of that internal resistance. In fact, what we call the terminal voltage between there and there, between that point, we call that delta V terminal, because it's the at the terminals of the battery, you actually have a delta V that's less than what the battery says on the side. Delta V terminal can be calculated by E minus I times this little r, the internal resistance of the battery, and that can have a significant effect. Let's take a look at this demo.
What I've got here is a demonstration of the internal resistance of a battery. The important parts of this demo is I've got a battery just hooked up to a voltmeter right here, and you can see brand new battery right out of the package. It's about 1.6 volts across the battery. But now what I'm going to do is connect these three holiday lights in parallel with the battery, and what that'll do is that'll draw current off the battery. Watch the voltmeter very carefully as this gets plugged in. Now you'll notice that the voltmeter went down, the voltage went down to about 1.5. I'll pull it off so you can see that again. There it is originally, it's 1.6. Plug in these lights in parallel. The lights are on and it's 1.5. That is because there's internal resistance, and that internal resistance is causing a voltage drop. Now if you want to see an extreme example of this, and I do not recommend this if you want to keep your battery around, I'm going to create a short circuit across the battery right here. Watch what happens when I connect this right here, creating a short. Watch what happens to the voltage across the battery. Here we go. I'm not going to do it for very long. Whoa, it goes down to almost nothing because there's such high current going through the battery that the internal resistance causes a major voltage drop. And you might ask, why is it that the voltmeter itself does not cause a voltage drop across this battery? Well, the voltmeter is very, very high resistance. So there's incredibly low current going through that. In fact, when the current is zero, the terminal voltage will actually equal the EMF. There will be no voltage drop across the internal resistance when there's no current.
Now, a lot of times we often neglect, when we're pretending it's an ideal battery, we often neglect that internal resistance. But in real life, you cannot. You must actually consider that internal resistance.